All right, welcome back. We are COMP397 in the winter 2020 semester, and it is week 4, part 1 of our broadcast. We're going to be talking about the vector and how we're going to use it today in our class. But before we get to that, I want to talk about the schedule. Oh yeah, there's this placeholder stuff I have to. So the schedule in terms of your project and everything else, I want to talk about this. So today, what we were supposed to do is collision detection, finite state machine. That was because we're sitting at week 4. But however, I'm going to probably do collision detection and response first today, because next week for your first playable, you need to be able to do some simple collision detection. Okay, so I'm kind of just swapping those out. So next week we'll do finite state machine and making multiple scenes. This week we'll do collision detection. Okay. Remember that next week you have your first playable that's due. And I believe your slot machine game is due week 6, if I'm not wrong, right? Yes? Yes. Okay, so this is not the way it's written. This is actually week 6. And we're going to swap these out. So first playable, collision detection and response. That's going to be this week. And we're going to do exercise 2, which is the finite state machine, next week. That's all. All we're doing is swapping those around because of the way things are this semester. Okay? Just letting you know. On that, in order for us to do collision detection and response, let's take a look and see what we have so far. So I want to bring up last week's project. So we'll be using the same project. I'm not going to get a new GitHub repo. I'm just going to use the same GitHub repo, even though it says lesson 3. We're still going to use lesson 3C from last week. Okay, so this one. I'm not going to update this week. And there's a couple of reasons for that. So if I use lesson 3C, that's the same GitHub repo. I'm going to bring up VS Code here. And I'm going to drag and drop in lesson 3C, just from last week. There we go. And let's just close off some of these files. So close them all off so we can start and see what we have. So this is what we have from last week. First thing you should do when you download your project is do a couple things. First thing is run your build configuration. So Control-Shift-B, first thing you should do. So why do you think this is a good thing to do, Control-Shift-B? Why would I do Control-Shift-B right away? Well, it's really important to do Control-Shift-B because if I don't do Control-Shift-B, that means that it won't start building my TypeScript. It won't be watching for any kind of changes. And then when we start building out our code, we're going to be like this. We're going to say, what the hell happened? How come my stuff is not transpiling from TypeScript to JavaScript? Well, we didn't press Control-Shift-B. Didn't press it, not transpiling. And then you're not going to know what the problem is. So that's one of the issues. So right now, because I'm using a watch task, it's waiting for me to build something in TypeScript and then convert it to JavaScript. Okay, part 2. I want to open up a new terminal and just try and see what I have. So I'm going to say light-server. And let's make sure I'm plugged in here, because if I'm not plugged in, sorry guys who are watching, if I'm not plugged in, performance is going to suffer. There we go. Yeah, so I have this from last week. I have this little thing. I made a couple of buttons. Remember this from last week? And when I click the reset button, it resets. If I could click me, it says clicked. It looks like it's a little window from Windows XP, right? And we have a couple of pieces of text here. And this is fine, right? But what I'd like to do this week is I want to create the idea of a game object, and I want to start talking about collision detection. In order for me to do this, I want you to think about what I'm going to build this week. So this week I'm going to start off by building a vector. And the reason why I want to do vectors is because I need to calculate the distances between two objects. Calculating distances between two objects, I need positions. I can get this information from the position, the x and y coordinates of each of the objects that we have on the screen. And remember, right now, for example, these buttons are just bitmaps. And if I look at my easel.js documentation, my bitmap class is here. And if I scroll down in my index, you can see that I have x and y coordinates. I definitely have that. I have an image, which I talked about last week, and some other properties that I have that are part of my bitmap class. Okay, so I definitely have all of this. There's a lot of stuff that's going on here in terms of all the things that I have. Okay, so these are all the different things, which is pretty awesome. Okay, these are all the things. But what I want to do is I want to calculate distances. And one of the things I don't have here is like, what's the distance between two objects? How do I do that, right? I can calculate the bounds by getBounds. And there's some other things that I can do here. Like, for example, maybe I can use the matrix, the actual object matrix, to figure some stuff out, or even transform things. I can set the transform or get the transform. I got those kind of things for the object. But this becomes a little bit more difficult for you guys, right? The other thing that I don't have is I don't really have a game object. Right now I just have a bitmap. And a bitmap is just an image. That's really what it is, right? What I want to do with you today in the second recording is I want to make a game object, right? And there's a couple of approaches I can take. One of the approaches to make a game object is I could use something called an entity component system approach, which is I create an entity, and the entity is very small. It's almost like a number, 1, 2, 3, 4, 5. It keeps track of all the entities. And then I can create components, separate components, like a transform component, some kind of rendering component, and other things. And then I can attach these components to the entity. So if I want to have an entity, a game object that is rendering, I can attach the component and do that. The great thing about this is, if I did it that way, is it gets great flexibility. That's the amazing part about it. And it also reduces my footprint for each of my classes. When I make each of my entities, the footprint is small. And I don't use inheritance for the most part. It's using data-oriented design. Okay. The challenge with that approach is it's very complex. It can be more complex to look at when you first look at it. And since you guys aren't students of game design for the most part, or game development, it's going to add complexity to your project, and I really don't want to do that. So instead, I'm going to elect to make this monolithic game object superclass, and all other game objects are going to come from that game object. They're going to derive from this game object superclass. The game object superclass is going to be, for now, a bitmap, right? And then I'm going to have several properties that all the other game objects that I use in my game are going to use. That's how it's going to be. And I'm doing this not because it's optimal, but because it's simple. Okay, just to let you guys know. And also, making a entity component system with JavaScript and TypeScript is challenging. Okay, so this is the first part. So the first part I want to do before I make my game object, I need some helper classes, and the first helper class that I need is the vector. So I'm going to start off with this one. I did this a little differently in the last section. I kind of made the game object and the vector kind of at the same time. This time I'm going to start off with the vector. So what is a vector? In math, what's a vector? A vector is some kind of object that has magnitude and direction, right? It's like a point in space, right, away from the origin. And we know if we take the origin and that point in space, there's an arrow that points from the origin to that point, whatever that point is. A vector doesn't have any idea of position. It only cares about its magnitude, the length, and the direction that it's going in. But it doesn't care about position. You can have vectors that are equivalent. They're pointing in the right direction. They have the same magnitude, but they're on different positions, and they're all equivalent. They're all the same, right? But it doesn't mean that they start in the same position, right? Here, what we care about is, when we think about vectors, we have to think about them as like little points. I want you to think about them as points, right? X and Y coordinates. And so we're going to call this vector a vector 2. There's different kinds of vectors. I can have a 3-dimensional vector, X, Y, and Z. I can have a 4-dimensional vector, X, Y, Z, and W, right? Or maybe I can use my 4-dimensional vector to describe color, R, G, B, A, where A is alpha, right? And we have different components. Think about this vector as a container that contains two components for us, X and Y. So let's make this class. Okay, review. When we make classes, for you guys, when you remember, if I make classes, the first thing I do is I make a file, right? So I go into Objects, add a new file, and let's call this file together vector2 dot ts. Now because I'm watching vector2, it becomes two more files, vector2.js and vector2.js.map. Okay, and the reason why this happens is because I'm using TypeScript and it's transpiling automatically because I got the watch task on. If you don't have these happen right away, you need to press Control-Shift-B on Visual Studio Code to enable your watch task. All right. All right, so my vector2 right now is empty. And remember what we did last time. Again, this is review. First thing is I want to put it inside of a module, my class. I don't have to do this, but I think it's better from a compartmentalization perspective. I need a namespace usually. I want to always use namespaces for organization purposes. So I'm going to call this module objects. There we go. So in my module objects, just like I did before, I need to expose, I'm going to use the export keyword, to export a new object, a new class called vector2. Okay? The vector2 class is not going to inherit from any other classes right now. It's going to be our own class. Okay? Inside any class, I want to have the following. Maybe some private instance members. Right? I want to have those. I want to have some public properties. I also want to have a constructor function, as well as private methods and public methods. Those are all things I want in my vector2 as well. Okay, so that's one thing. Now, when I start creating a class, I got to think about this. So let's start with the private instance members. So for private instance members, they're going to be private. In TypeScript, you can use the keyword private as an accessor, right? And I can say that I have two. I have a underscore x, which is a number, and I have a private underscore y, which is also a number. Guys, remember last week when we said what these things are? Underscore for us, if ever I put an underscore in front of my variable name, it means private. That's what it means. So if you see an underscore, that's the private member variable, okay? Yes?
Is this a convention?
Yes. Yeah, it's a convention. And it's actually in C++, we don't just use underscore, we use M underscore. We say member variable that's private. And sometimes we even go further than that. Member variable that's private, that's a pointer. M underscore P and the name of the variable. And why? Because it's easy for us to say, okay, I want to look at all my private variables. Which ones are they? All of them. Here they are, right? I want to look at all my other variables. Which ones are they? So that's how it does. So definitely a convention. All right, but we get these little squiggly underlines, and it says, hey, property X has no initializer and is not definitely assigned in the constructor. Well, we don't have a constructor yet. Let's make that. So to make a constructor, we use the keyword constructor. And maybe in the constructor for a vector, we want an x and y coordinate, right? So I want to say x, which is a number, and y, which is a number, right? Things to note is last week we said if in the constructor or in a method you set values, then what happens is you create optionals, right? So if I say, well, by default the value is 0. If I do this, I say the default value is 0. And if I hover over the constructor now, you can see that for a vector2, if I don't enter the value for x and y, then I just set them to 0. That's all I'm doing here, okay? I'm setting them to 0. There's a couple ways I could do this, and if you notice here that I have this private instance members and I have these things here. And what you normally would want to do is something like this. This dot underscore x is equal to x, and this dot underscore y is equal to y, and you notice that that problem goes away. And this is nice, but what I'd rather do is I want to have getters and setters. And now you might say, wait, I hate getters and setters. I did C# and Java, and I don't have any reason why I want to do getters and setters because it's useless. I have private instance members, and then I make public getters and setters, and it's like I have access to the private stuff anyway. Why not just make everything public? Wrong. This is wrong. The reason why people think that is because they don't understand the power that you can do. If I just set a value to an instance member, the set value is set. That's all I can do, set a value. However, with the getter and setter, the advantage to using those, and by the way, there's nothing wrong with making some things public sometimes, right? But the advantage of making things public properties and private instance members is in the properties are functions. So let's say I want to track when I set something to a value to an instance member. I can't do that easily if I just assign it directly. If I go through the method, I can track when something is set. I can track when something is get. I can do additional things at the same time, simultaneously. When I'm setting something, I can do something else too. I can't do that very easily. I have to set up event handlers and all kinds of other observers to have that happen. And so actually it saves us to do it that way. So for us, we're going to practice doing it the harder way, right? By making use of public properties. So we're going to say that to make public properties, we need getters and setters. And by the way, in JavaScript, there is no such thing. However, in TypeScript, if I go back to TypeScript, if you go to typescriptlang.org and if you look at classes, underneath classes, right, you're going to see an area that has accessors. And there's a link. So here's the accessors link. This is the accessors. And I'm just going to take this link. I'm going to copy this link address so we can always find information about accessors. I'm going to populate it inside of your week 4. So I'm going to go to new link. And here's the link for that. And this is TypeScript accessors. So this is all around. There we go. TypeScript accessor. So you can always just click there if you don't know where to find it and go to that particular link and it'll show you the documentation for TypeScript accessors right here. So what are they? We want to use get and set. And it kind of looks like this, where we use get, whatever the name is. It looks like a function, and set, whatever the name is. And we need some kind of parameter to set the value. And this is how it looks. Notice that there is no public keyword here. I don't have to do public property. One thing you cannot have, I've never seen, is a private property. Can't have that, right? Which kind of defeats the purpose. If you have private properties, make them instance members, right? However, you can certainly make static properties as well. You can do statics. And you can also make abstract classes, which we're going to do today. So public properties, they look like this, get and set. Okay, so let's go back to this and do this. So we're going to say, let's make the getter first. So get x, right? It's going to look like a method for now. Get x, it's going to return a number, right? And I'm just going to, right now, it's just going to return the private instance member. So return, right, this dot underscore x, right? And I can do the same thing for y. Get y. Oh, so I can do the same thing if I don't mistype like that. Return this dot underscore y. So that's kind of the same as what I'm doing here. I can get stuff this way. And setting is the other way around. Set x, some kind of new x, new value, which is a number. And I can say that this dot underscore x equals to new x. And I can do the same thing for y. I can do a setter, set y. So new y, and then a number. And this dot underscore y is equal to new y. Okay, so that's our getters and setters for our vector. Are we good so far? And this is good. So what this does is it gives us, I want you to think about the getter and the setter as our front man, our intermediary, our delegate. You never actually meet the data member. You talk to somebody else first, right? That's the property. And then the property talks to your data member afterwards. It's almost like your middleman, all right? Or middle person. They're in the middle between, the actual user and the data. They come between the user and the data, and they allows the messaging to happen here. I can have additional things here. Like I can do every time I set and get a vector property, I can write things out to the console, right? I can do all kinds of troubleshooting. It's also very highly testable if I have getters and setters, because I can test these functions, right? Okay, so that's other reasons for using. So this is the basics. I want to be able to do this with my X and Y. But if I only did this, who cares? This isn't powerful. We need some additional functionality here to help us, right? So here's where we have some private and public methods. I'm going to start with public methods. And one of the public methods that I want to have is add. One thing you cannot do with TypeScript right now is you don't have operator overloading. It's not a thing in JavaScript or in TypeScript. You can't overload the equals operator. You can't overload the plus operator. You can't do those things like you get in C# and Java, right? Or even in C++. So we have to make a new public function called add, and it's going to take the right-hand side, right, which is going to be a vector2, right? And what it's going to return is nothing. It's not going to return anything. It's actually going to modify my current vector to add the vector that's on the right-hand side. Okay, that's what it's going to do. So the way this works is I would say that this dot x, as an example, is equal to the right-hand side dot x. I want to add that on, so plus equals to the right-hand side vector. And this dot y plus equals the right-hand side y vector. So I'm going to add that on to my vector. I just add the two vectors together. Okay? So I'm just calling it right-hand side because it's the right-hand side vector. That's what it is. So there's two vectors, my vector and the right-hand side. And instead of saying this is equal to this, I say my vector dot add, and then pass in the new vector in the middle, and it adds those two vectors together, and it stores the result in my current vector. That's what it does. All right, and I can do the same thing for subtract. Subtract. So I have something I want to subtract from the right-hand side. Subtraction is really super important because it can do things like help us find direction. We'll talk about that in a bit. I can say this dot y minus equals to right-hand side dot y, and I might as well do the x. I don't know why I did the y first. This dot x minus equals to right-hand side dot x. There we go. Okay, so let's add and subtract. Yes?
I'm sorry, I'd like to make a question about TypeScript.
Tell me.
Yeah, so when we create the setter, we didn't say void, and we didn't say public.
Because the setter, we never say public on any of these things. That's one thing we have to do. One thing to note is when a number, we don't say void. If I said void here, watch. It actually gives me an error. It says that a set accessor cannot have a return type. That's just the way it is. That's the TypeScript thing.
So how about the get?
Getter has to have a return type because you want to return, right? As a number. But the setter, no. Right? So it doesn't allow me to.
The keyword set.
Set.
It's because it's the keyword set.
Yeah, and set is public. It can't be private. You have no. So you don't put public get, public set. You don't have to do that.
Okay.
All right.
Okay.
All right. So
The keyword
get and set. Yeah, get and set. If you use get or set, it's public. It means public.
Okay.
Okay. All right. Next, I want to add, subtract, and I want to scale. So I want to I want to scale something. I want to scale it with a scalar. Whatever the scalar is, it's a number. And what it's going to do is return void. I'm not returning anything. I'm just modifying my current vector. I want to say then that this dot x times equals to the scalar, whatever the scalar is, and this dot y times equal to the scalar. All right? So I'm not multiplying two vectors together, I'm scaling one up. I'm scaling it up. Now this is a uniform scalar, right? So it's happening on both x and y. I can have a non-uniform scalar, right, where I have some scale on the x and some scale on y, right? But I don't have that option here. Okay, I'm not doing that right now. Okay, so these are some public methods, yeah? Some easy ones. I also want to keep track of my magnitude, all right? But I want my magnitude to be something that's calculated. So I can have a calculated property as well, right? So here's something that I can have. I can have X and Y, and I can have magnitude as a property. Let's do that. Because remember, a vector has magnitude and direction. So private, we'll call this magnitude. And it's going to be a number. Okay, magnitude. By the way, the reason why it's not complaining about my constructor doing this, I want to talk about this in a bit, but I want to just get rid of it for now, okay? I'll come back to my constructor in a second. Notice it is complaining now about all of them, and I'm okay with that. But let me fix my magnitude now. So I want to... Do I want to set my magnitude? Ever? Not really. I never want to set my magnitude. I want to get my magnitude, right? My magnitude is a calculated property, right? Magnitude is only going to be set once. I'm never going to set it again, right? When the vector is created, right? Or when the vector is modified, that's when the magnitude changes, right? My magnitude will change every single time I modify an X or a Y. My magnitude will have to change as well, right? Because magnitude is based on the distance from the origin in some ways, okay? So I need a setter and a getter, but the setter is only going to happen in very rare instances. So let's do the getter first. Get magnitude. And when I pass in magnitude, I'm going to return a number. So that's what it's going to return. It's a number, not a vector. And I'm going to say that in order for me to get magnitude, I'm going to return something. The way you calculate magnitude is I use basically Pythagorean theorem to do it, right? Remember how we make a vector? X and Y, right? And I want to find the distance or magnitude. The way I do that is I take, I use the Pythagorean theorem, which is c squared is equal to a squared plus b squared, or c is equal to the square root of x squared plus, or a squared plus b squared. So here I'm going to do the same thing. I'm going to say that I'm going to return math dot square root, and that's what I'm going to do when I return my my magnitude, and that's when I get magnitude. But I want to store this thing somewhere. I want to store my magnitude somewhere first. I want to say that this magnitude is equal to this, and I'm going to return that. So when I call magnitude for the first time, I'm going to say that this that underscore magnitude, right, is equal to math dot square root, right, as an example. And I'm going to pass in my x and y coordinates. So I'll say that this dot x, sure. Actually, I'll put underscore x. This dot underscore x times this dot underscore x. I want to calculate those two values, right? Plus this dot y underscore y times this dot underscore y. Okay, so that's kind of the magnitude. But if I do this, it's like I'm using the setter. I'm kind of using this, and I'm setting this up, whatever this, when I calculate the magnitude, right? So that's something that, I mean, it has to be calculated, right? So I'm just going to keep this up for a second. And then what I want to do is I want to say that I want to return this dot underscore magnitude. So I want to first calculate it, whatever that is, and then return it. So now you can see that our getter actually does those things. When I get magnitude, I take the current x and the current y, and I calculate magnitude for myself. Okay. So how do I set magnitude? Well, it doesn't make any sense, is what I'm saying to you. It makes no sense for me to set magnitude to something. I can get magnitude, but I can never set magnitude, not really. But I need initially some kind of way of setting the magnitude in the first place, right? Because otherwise, I'm not going to have this. I'm thinking about it from a how to make this thing perspective, right? So normally a setter looks like this: set magnitude, and then I have some kind of new magnitude. Right? New magnitude, which is a number. And I'm going to say that this underscore magnitude, well, that's equal to new magnitude. So there's a couple of approaches we can take. One is when we calculate magnitude, as soon as we get it, we're just calculating magnitude again. But this breaks our rule a little bit of what getters and setters are all about. I mean, I want it to be a calculated property, but I wanted to calculate it once, somehow, right? In fact, maybe there should be another method called calculate magnitude that I'm calling. That makes more sense, because then I can call it more than once. So for now, this is okay, but I don't want to do this, not here. Right? When I get magnitude, I just want to return the value. When I set magnitude, I want to actually change the value somehow. And usually this might be a private function that I do. I probably won't do this outside of there won't be a lot of call for this, is what I'm saying. In my constructor value, I can have a private method to do this, though. I can create a private method. I'm going to call this set, kind of set magnitude, like private, or calculate magnitude, compute magnitude, whatever you want to call it. Let's do that. So I'm going to say private method called compute magnitude. I did this differently earlier today, right? Compute magnitude. And it's going to return a number, okay? So it's going to return this, math.square root, blah, 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 blah. That makes sense, right? So I take x and y and I return the magnitude. And then what I can do is, in my constructor function and in other places, I can compute the magnitude again. Okay, so I can go in my constructor function, I can say something like, well, you know what? This dot magnitude is equal to, compute magnitude. Because I want to do that for the first time. And by the way, if it says, it should be like this, because it's a property. Okay, so I want to compute the magnitude and I want to set it in here. So why did I do this? Because what about when, and this is what I didn't take into account, what about when x changes? Or when y changes? If x changes or y changes, we should compute magnitude again. It's changed, right? So we need to do this. So inside of our setters for x and y, so if I go to my set x, then after I set my x, then I compute magnitude again. This dot underscore compute magnitude, right? Because I've changed x, right? So then the magnitude will be different. Remember, magnitude is x times x plus y times y, right? And take the square root of that. So that's one thing. And the same thing goes when I set y. When I set y, I want to also compute magnitude, right? But remember, computing magnitude, it just returns a value. So I can't just do this, right? I need to say that this dot underscore magnitude, right? Or this dot magnitude is equal to this. I need to do this thing over and over again. This. Now, are you guys understanding why? So I change something, a value. I have, right now, let's say, for example, I have a vector that is 3 on the x-axis and 4 on the y-axis. And my hypotenuse, my distance is 5. 3, 4, 5 triangle. Okay, that's what I'm making. So it's 3 and 5. What other magic triangles do you guys know about? There's other kinds of magic triangles you can use, right? Some other value, right? Let's say, for example, I want to move it to 5 and 5. Right, so I want to move my vector from 3 and 5 to 5 and 5. Now my magnitude is different. My magnitude is going to increase because my x has changed, right? So that means I have to calculate it again. Every time I change my x and y coordinates, I have to calculate magnitude again. Okay, makes sense? So I have magnitude, and we're going to come back to why this is red in a second. And I also have something else, another property that I want to have. Squared magnitude. Square magnitude. Why? Because this uses magnitude, computing magnitude uses square root. And computing magnitude every frame, if I ever had to do that, is computationally expensive. Sometimes I want the square magnitude of something, which is just this part. I want that part too. So I can do that. I can say that private square magnitude, I'll call it like this, magnitude, which is also a number. And let's have some getters and setters for that too. So get square magnitude. It's going to return number. Wow, terrible at typing today. And that's just going to return this dot underscore square magnitude. And I'm also going to set square magnitude, which is, you know, some kind of new square magnitude. Also a number. I'm going to say that this dot underscore square magnitude is equal to new square magnitude. Okay, so that is my getter and setter. So far, so good. However, I can't use the compute magnitude anymore to calculate this. I need a new method called compute square magnitude. So private underscore compute square magnitude returns a number. And all it's going to return is this part, no square roots. Oops. So square magnitude means I'm not using the square root. I'm just returning the squares. And why I want to do this sometimes is because I can compare squares. I don't just have to compare the actual value, right? So because I have this, then I can just use that in here. So I can say, well, this dot square magnitude, right? Compute. Does that make sense? Because this is what I'm doing here. I'm taking the square root of the square magnitude, and I'm getting the actual magnitude. So this is okay. Are we good so far? Yes? Have I confused you yet? Math. Told you. We have to do a little bit of math. So why square magnitude? Because sometimes I don't want the square root. I just want the x's added together. And the y's added together. Okay, cool. So now that I have this, I need to do this as well. I need to calculate the square magnitude every time I change my stuff. When I do x and y, if I change my x and y at all, right? So x and y, I need to also do, I have to compute the square magnitude. So I'm going to say that this dot square magnitude is equal to this dot underscore compute square magnitude. I want to do both computations when I change my my x or y. And this way I have more accuracy. I have more accuracy when it comes to changing any of those two values. If I change x and y, my vector already knows what my magnitude is anytime I do it. Okay? This is the difference between setting a value and having a property. My property is now doing three things. It's setting the value for x and y, and it's also setting the square magnitude and the other magnitude. Both. It's calculating all those things for me, right? So why do I need that? Because I want my vector class to be smart. Each vector is going to have a lot more information than normal. It's not just going to have x and y coordinates. It's also going to have other information that it keeps track of. Okay? This one?
Yes, it's set.
Yeah, sorry. I know I'm trying to go slow, but you know, sometimes I go a little bit fast. All right, any questions around this so far? So pretty simple stuff. Magnitude, square magnitude. Okay. What I also want to do is I want a new function. I want sometimes to normalize. I want to normalize my my vector as well. Do we know what normalization means for vectors? Math. How about you guys? You guys know what normalization means? If you don't remember normalization, how about the unit vector? Do you know what the unit vector is? What's the unit vector? 1. That means that the distance, right? The magnitude, it's a vector with a magnitude of 1, the unit vector. Okay, let's figure this out. Imagine if I had a 3, 4, 5 triangle again. 3, 4, 5. How would I normalize that triangle so that so I always get a magnitude of 1? So imagine this, I have 3 pixels, and then I have 4 pixels. So 3 pixels across on the x-axis, 4 pixels up. And I make a triangle that's 3, 4, 5, right? That's my triangle, magic triangle, right? So my distance, my magnitude is 5 now, right? But I don't want a magnitude of 5, I want a magnitude of 1. What number does x and y have to be for me to have 1? The way I figured this out is I use the magnitude. So I take my calculator and I say, okay, if I have 3, I divide it by my magnitude, which is 5, and then I have 0.6. So 0.6 will be on the x-axis, right? And if I take 4 and divide it by my magnitude, which is 5, I get 0.8. 0.8 on the y-axis. 0.6 and 0.8. Okay. If I do Pythagorean theorem with 0.6 and 0.8, does it equal to 1? Let's see. So if I say 0.6 times 0.6, that's equal to 0.36. 0.8 times 0.8 is equal to 0.64. Let's add 0.64 here, plus 0.64, and I get 1, right? And if I take the square root of 1, because that's Pythagorean theorem, I get 1. So if I just take the length of each component of the vector, x and y, and divide it by the magnitude, I get 1 for the total magnitude at the end. So let's do that. So if I might have another function. The function is going to be public, and I'm going to call this function normalize. Normalize. And what normalize is going to do is it's not going to take any variables, no parameters. And what normalize is going to say is I want this dot x, right, to be equal to this dot x divided by this dot magnitude, right, the actual magnitude. And I want this dot y to equal to this dot y divided by this dot magnitude. Now we're going to have a problem. Why is that? I'm setting x and y, but when I set x and y, it recalculates the magnitude for me, which means the second value is going to be wrong. So this would be what I want to do at the end. This is what I want at the end. But for now, I want some temporary value. So we're going to call it like temporary x. We'll say like let temp x. Actually, we'll just call it temp x. And we'll say that let temp y, right, equal to x, some value that I'm going to get. It's going to be a value, a number that is going to be like if x was 3, I would divide it by 5, I would get like 0.6 as an example. And if x was 4 and divided by 5 magnitude, I would get 0.8. And then once I have both those values, then set x and set y. So I'm going to say that this dot x is equal to temp x, and this dot y is equal to temp y. Okay. Temp y. There we go. Okay. Other ways I could do this as well. But basically what I'm doing is I'm getting the magnitude, right? I'm actually changing my vector so that it has a unit length of 1. And I should do that. I could use something called document this. Remember document this last week? I said this / double star and then choose document this. And what document this does is it's going to give me a way of documenting, and I'll say that this method sets the current vector to a magnitude of 1, the unit vector. Okay, that's what this method does, and you can do that for every method you make. If you want to comment. Does that make sense? Magnitude of 1. All right, cool. So I have a couple methods: add, subtract, scale, and normalize, which is super important. This one here, super, super important. Normalize. Okay, now I want to create some public static methods to help me, helper methods, so that I can do other things with vectors. Okay? Don't panic, guys. It's going to get easier. All right? Trust me. All right, so we kind of did up here, we made this private methods. I made public methods. I'm going to make another area here that's called public static methods. Public static methods. Who remembers what public static does? When I make something static, a method, what does that do for me? What's the difference between a public method and a public static method in C# or in Java? What does it do for me?
A static method, you don't need to instantiate a new object in order to use that.
I don't have to instantiate a new object. Very good. So I can do something like this. Public static. And my public static method is going to be called dot. All right? So I want the dot product, right? The dot product is going to take two vectors, the left-hand vector and the right-hand vector. So left-hand side is a vector 2. And the right-hand side is a vector 2. And it's going to return a number, right? Because it returns a floating point number. If I can actually type properly without typing extra characters. So how does this work? It returns dot product x left-hand side dot x times right-hand side dot x plus, left-hand side dot y times right-hand side dot y. Okay, so it looks like this. Left-hand side dot x times right-hand side dot x plus left-hand side dot y times right-hand side dot y. Okay. If you want to be just from an order of operations perspective, you don't need to do this, but you can also put brackets if you want. Not a problem. Just so you can see that this is what's happening. I take the first two things, I add them together, I multiply them, and then add them together, and the second two components, the y components from both vectors, and add them to multiply them together, and then add those two things together to get the dot product. Dot product is great for doing things like finding the angle between two vectors. I want to find the angle between two vectors, I use the dot product, right? It helps us with collision detection. Okay, so dot product is definitely something I want, right? I also want to check to see if a vector is, what if a vector is normalized? I want to see the normalized vector. I want to take a vector that exists, that's already normalized. Instead of normalizing it, I want to see what it would be if it was normalized. What would it be if I normalize it? I don't want to, because this function here, normalize, actually changes my vector. It changes my original vector. It doesn't create a copy or return something. It actually changes the vector. But I want to see sometimes what would be the length. What would be the length? And why is normalization great, guys? Well, imagine if I want to find the distance to you, right, as an example. I take your point, your vector, and I subtract it from my vector, and now I have the distance between me to you. But it's from the magnitude is from me to you too, right? I don't want the distance from me to you. I want the direction. So all I do is I normalize it. Now my direction, my distance instead of my magnitude is the same bit this long. It's only unit vector length, but I'm pointing at you, right? That's why normalization is great, okay? But sometimes I want to keep my original magnitude. If I normalize, my magnitude is gone. I lost my values, right? I don't know what, if it was a 3, 4, 5 triangle, now it's a 0.8, 0.6 triangle or whatever, right? I've lost my values. So sometimes there's a value in what would it be if it was normalized? And I want to return another vector. So I can do this as a public static. So I can sit there and say, okay, public static normalized. And I want to take whatever the vector would be normalized, and I want to return a new vector 2. So I want to do a new vector, right, as an example. So I'm going to say let vector equal to a new vector object. And I want to say that I want to take vector.normalize. So this normalizes the object, and I need to use normalize like this. Vector.normalize, right? So this changes this vector to unit length, whatever it is. Now I want to pass in, here's something I want to pass in. I want to pass in the vector. So this is the other vector. So I'll say you know, kind of the right-hand side vector, whatever that vector is. I want to take that vector, whatever it is, the x and y coordinates of the current vector, right? Whatever the current vector is, I want to normalize it. So I want to make it so that I don't, by the way, should this be normalized? Or maybe it's not public static. Let me take that back. It should actually be part of my group here. So public, it returns a vector 2, but I'm normalizing my current vector, where my x coordinates, this dot x and this dot y, is something that I'm going to make a new vector. I'm cloning the old vector into this vector and then normalizing it, but I keep my own vector. And then what I want to return is vector. And what this does is it returns the value that I would have had if I normalized. Okay? I'm not normalizing my actual vector. I'm taking my current vector, calculating what it would be as the unit vector, and returning that. Okay? A useful little function. So normalize actually changes the vector. So this is, it sets the current vector, and normalized does something different. This, it calculates or computes the vectors, the current vector's direction. Current vector's direction without changing it. That's what it does. This changes it. Okay, so a couple of methods. Other methods I want is, what would be if I want a vector that's 0 sometimes. I want the 0 vector. So I can do that by going here and going public static. Let's call this vector 0. It's going to return a new vector 2. And it's going to return a new vector 2 that's just 0, 0. The 0 vector. Sometimes also I want a public static vector that is 1 on both sides, a length of 1 on both sides, x and y. So return a new vector 2 that has 1. Now that's kind of, those are very useful little things I can use for adding and subtracting stuff, or calculating positions and so on, or direction. All right. I also want to have some utility functions for finding out what is up from that vector, what is right, what is left, what is down, and I want to multiply that. So I can do public static up. Remember that up in this framework is x is 0 and y is -1. Remember, up is negative and then down is positive, because we draw x to the right and y down. That's how we're drawing, right? So it helps us to do this. If I return a new vector 2 that is 0 on the x-axis and -1 on the y-axis, right? That would be up. I also want to do down. So that's another one. Down, where down is 0, 1, right? I also want to do left. So this would be left, where this would be -1 on the x-axis and 0 on the y-axis, right? And finally, we want to do right, which is just positive on the on the x-axis and nothing on the y-axis. Okay, so that is kind of some convenience functions. Sometimes we want to show this. I also want you to think about normalized as your forward. That's kind of your forward position. Where are you looking? Where are you pointing to? That's your normalized value, right? If I look in this direction, you know, example at 30 degrees, right? What is my normalized value, you know, when I look at 30 degrees? All right, so those are kind of some vector helper methods that we can use. And there's other ones. There's other ones. And what I'm going to do, guys, instead of being exhaustive here, because I can make an exhaustive list of mathematical functions that'll help you guys. I'm going to add 2 more. one of them, and that's it. We'll add distance and squared distance. And I need those things for collision detection, right? So let's do distance first. So this is a public static, and I'll call it distance. And it's going to be between point 1, which is a vector 2, and point 2, which is a vector 2. And it's going to return a number. So the way you find out the distance between two vectors is you do Pythagorean theorem. So this is like Pythagorean distance. That's what it is. Okay? So Pythagorean distance, again, c squared is equal to a squared plus b squared, or c is equal to the square root of a squared plus b squared. I want to find the difference in x's. So let difference in x be equal to p2 dot x minus p1 dot x. And let the different in y's, actually let's just call it difference in y's and x's like this so we know what that is equal to p2 dot y minus p1 dot y. That's part of the formula. I'm just breaking it down so it's not all in one place for you. And then I want to return math dot square root, where I take the difference of x's squared. So difference of x's times difference of x's, right? Plus difference of y's times difference of y's. It looks very similar to the magnitude, but it's not. Why is it not? These are two vectors. There's two vectors I'm using. So distance between me, my vector, and your vector. Magnitude is the distance from the origin, for me. That's what that is. Make sense? So distance, again, if I was to use distance as a calculator to figure out the distance between 2 points, and I did this every frame, 60 times per second, I'm using square root a lot. Square root, bad. Mathematically, it's computationally expensive, right, for me to do this every frame. It's better for me to compare squares. So this is okay once in a while, but I don't want to do this all the time. I'd rather have squared magnitude or squared distance. And the way that works is it's very similar to distance. Just going to copy paste. However, instead of distance, we'll call it square distance or squared distance. And squared distance takes P1 and P2, but instead of using math.square root, we just take this out. We just do this part. That's the squared distance. Okay, that gives us enough to do what we need to do now. So a little bit of math. However, we still have one more problem to solve. And it's this problem up here. So have you guys got this already? So distance and squared distance. How about this problem? What the heck is going on here? How come I'm getting all these errors here? It's saying that property x underscore x has no initializer and is not definitely assigned in the constructor. Well, there's a reason for this. Because in the constructor function, and again, if you look at this, these are public properties. Did I spell that properly? Yes. Here's the constructor, and you notice what I'm doing in the constructor is just calculating the magnitude, but I'm not doing anything with x and y. What I'd like to do is say something like this. This dot x is equal to x, and this dot y is equal to y. And you'd think that this would be good enough. Because when I do this dot x and this dot y, well then, it kind of does this already. It sets the values for x and y, but it doesn't know that it's going to. It's a little bit dumb this way, and I'm not sure why they did this in the latest version of TypeScript, but it doesn't like this. If I do x and y here, well then it calculates the magnitude, it computes the magnitude based on my x and y coordinates. Remember, every time I set x, calculates the magnitude. Set y, calculates the magnitude. So I don't need to do this here. However, I still need to take care of this, and it might be as easy for now to set them as zeros. So let's just do that. Let's just set these all, we'll initialize all this to 0, right? And if you're not happy with this, so you don't like this, because you're like, wait, this breaks the rules, right? Because you're not supposed to do things, and you're not supposed to initialize while you're declaring. That's not good, right? If you're not happy with this, you're like, wait, Tom, I don't like that, right? That's okay. So what you can do instead is you can make a little private function, which a lot of people do. Let's call this private function initialize.
How about to set the values inside the constructor?
We can do that too, but that's I want to use the properties for that. It's better. So I can do this, right? Initialize is actually going to return void. And I can just do initialize all this work that I'm doing up here. Bear with me while I do that. I can just use initialize to do it here. So I can say that this dot, right? And you're going to say, but why, Tom? Why? And because it breaks conventions when we initialize when we're declaring. It's not good. And I'm still going to do what you're telling me to do, but I'm going to do it in another function because I want to hide the initialization piece away from the constructor a little bit. The constructor should be as clean as you can make it by convention. All right, so this initialize does everything I need to do, but I'm going to call this initialize in my constructor, which is exactly what you're saying. Call it in the constructor. Yes. So first I initialize this dot underscore initialize, which is a private function, right? So it's not something that's called. Does it satisfy requirements if I take these away now? And you're going to see, even if I did this, right? I'm just going to show you this, that TypeScript is not happy. It wants me to definitely either do what you're telling me to do, right? Because it doesn't know if I'm ever going to make it to initialize. That's why. So let's just do what you told me. I'm just going to take this part stuff, this right here, and just replace it in here in the constructor, and just say, as an example, initialize member variables. They're just reinitializing to 0. I'm just setting them all to 0, right? And then I don't need this function anymore because it's not going to do anything anyway. It wants me to do this, okay? And then I can leave this the way it is.
So now we have to call to computer magnitude, right?
Well, no, I do it once I've set this
Okay.
x and y. It's done.
Okay.
Yeah, we're good. Once we've done this part, this sets the value. This sets set x and y. All right. And once it sets x and y, then, like we said before, x and y does all that.
Great.
Calculated value. All right. So this is our vector. Questions around the vector class. Are we done with the vector? Can we use the vector right now? Right now, can we use it in our code the way it is? The way with what we've done? This is a trick question, actually. The answer is no. You can't use this vector right now. If you do, it's not going to work. It's not going to work because, remember, JavaScript requires us to do changes in our index.html. Whenever we add a new class, we must list it here by default, this in the way we're doing it, inside of our index.html. Okay, unless we use some kind of module loader, which we're not doing. Okay, so again, I'm going to make these ones. I'm making a new script, source, and the source is going to be scripts, objects, and then vector. Now we can use it. Now that we've connected it, once we connect it to our index.html, we're able to use it. Guys, for your midterm tests, you need to know this. Midterm tests can be practical. You need to know when we create any class. I'm not going to ask you, by the way, to make anything like this. All right? I'm not going to ask you to make a vector, but you should know how to make other classes, right? And when you make a class, you must connect it into my index.html before it can be used. Otherwise, you'll get some weird constructor error, like we showed you last time. Okay, so you need to connect it here. So now that I can do this, I can make use of this class. Let's try it out by default in my game.ts. So my game.ts right now, I want to try this out. I'm going to go to my main, and I'm going to say that let vector equal to a new objects.vector 2. I want to pass in a number 300 and 400. and I want to console.log the vector dot magnitude. Okay, this tests out whether it takes 300 and 400 and calculates magnitude for me. Okay, let's see how that works. So I'm testing it out here. I'm not really using the vector yet. I'm just trying it out. Go back out, go back to my website. There it is. And let's take a look at my console. And what do I get? 500, which is right? Remember, 300, 400, 3, 4, 5 triangle. That means if I have 300 and 400, it makes the magnitude 500. All right, what about if I want to see if it's normalized? So I want to see my vector2 dot normalized. Normalized. What it would be if it was normalized, right? So what's my vector2 normalized? And you're going to see when it returns, right? If I go console, that I get this, a vector2. It's a magnitude of 1. And this is perfect. The x coordinate is 0.6 and the y coordinate is 0.8. That's what it would be. It returns another vector, right? That's what it does. There's my x coordinate and my y coordinate. And here's my square magnitude and my magnitude. Okay, cool. I like that. I like that. Those are good things. So it looks like it's working so far. How about if I wanted 2 vectors? Let's say we'll have vector 1, which is, I don't know, 100, 100, 100, 200. Let's make it a little more interesting. And I'll do vector 2. I'm just testing it out to see if it works. Vector 2 is equal to a new objects.vector. And we'll make it so that it's 300, 500. Okay, cool. And now what I want to do is I want to use the objects.vector. Let's do a console log. I'm not sure if this will be right, but let's do a console log of vector 2. So objects.vector2 dot distance between those two things, vector 1 and vector number 2. Okay? So that's how the distance function would work. Vector2 dot distance, and then you pass in 2 vectors. And then it'll compute the distance and return it the square root of the distance, the Pythagorean distance. So how does that look? And what does it look like? 360. So it looks like that's working. All right. If you want to check to see what the distance is, right? You can compute the distance by yourself. What about if it was if it was a squared distance? It would be 360 squared. So squared distance, that's going to be a much bigger number, right? So what is that number now, right? That makes sense. 360 times 360 or whatever that is gives you a much larger value, and we don't care because this looks pretty good. Okay, so looks like my vector is working. Okay, questions around why I made my vector, why I'm doing this kind of stuff, right? Why? Because we use vectors all the time in games. I want to calculate the distance between 2 objects. I want to see that one object is overlapping with another object. I use vectors for that, right? I want to know the position of my object in space, right, compared to the position of another object in space. I want to know the angle between 2 objects, right? I need to have some kind of construct for this, and vector2 is a great construct. By the way, Create.js already comes with something called a point. And a point gives you x and y. But the challenge with using a point class is it doesn't have magnitude and it doesn't have the other stuff. You have to calculate all that yourself. You can store it somewhere else. And if we're going to go there, then I don't need the class. I'll just make my own. That's why I did. Okay, so, and to show you this, if you go back up to easel.js, you can see that easel.js has a point class. Here's your point class. And the point class is pretty cool because it gives you x and y coordinates, but it only has these methods, set values. I can convert it to string. Hey, that's something we forgot to do, a toString function. I want to be able to output a vector as a string, right? So in other words, instead of me just printing x and y, I want to output a string that shows me coordinates inside brackets. That's a great little function. And you guys should know how to do that stuff from C# and Java. ToString, right? Let's make that function, then we'll be done with the vector. All right, so again, it should be a member function. So a public function that's a member function, not static, right? So I can do something like public, we'll call it toString, and it's going to return a string. That's what it's going to do. So it's going to return a concatenated string. So we're going to start using just concatenation for now. So we'll say that we'll open up a bracket and then add in the x coordinate, right? So we'll say this dot x will return x, and then plus a comma and a space, right? And then plus this dot y, and then plus a close bracket. And that should give us everything we need for our vector, right? So we're going to return a string like this. Makes sense? So we can actually print out our vector nicely. What does it look like, right? And sometimes the toString function is a great little utility function for us because we want to show what our values are and we don't know what they are, and this helps us. So a good example of this in use is if I go back to my game.ts, instead of doing what I did before, let's suppose I don't want to do this. I want to just do, these are just tests anyway. I want to console log vector1.toString. And I overload my toString function. And once I do this, I go back to this. Then you can see that it gives me 100, 200 nicely, right? So it's a nice output of what my vector is, which is good. All right, this is great. But what I want to do with this is I want to put this up on GitHub. So I'm going to go to home. I'm going to go add all these changes. And I'm going to say added vector2 class. That's what I did, right? Here's my vector2 class. I'm going to commit and push. And now you should have all that up on GitHub. Remember that if you don't know where my GitHub address is, you can always look up our GitHub repo at github.com/Centennial College. And if you look at Centennial College, there's lesson 3C. That was the one I was using for last week. And you can see that these are all the changes that I made. Under scripts, you can see that I've added the vector class in the objects folder. And there it is. It gives you both the vector and the TS file along with the JS file, which is this one, which is pretty long. You can see the JS file is way longer than the TS file, way longer. Okay, so all my files are here. For the test, remember that it's going to be open book and open internet. You can use anything I've given you. If I've given you a vector class, any template that I've given you, if I share with you online, or anything that we've done in class together, it's yours to use. All right, so it's not going to be closed book. It's going to be open book, open internet. Okay, like the midterm test. That's going to come up in 3 short weeks from now. Okay, 3 short weeks from now. Okay, so cool. We've done this part. Let's take a short break. I'm going to stop the recording now. We've done our vector class, and when we come back, we're going to create our game object. All right, which is the next big step for us to start doing collision detection. Okay.